equals 60. Okay, and then we'll get length f over sine of 60 degrees equals, you've got an embarrassment of choice, but go back to your original data, don't use something you've calculated when you can avoid it. So 12 over the sine of 72 degrees means that f little f is equal to 12 sine 60 degrees over the sine of 72 degrees. No point in substituting in root 3 over 2 because it's easier to type sine 60. So that's equal to fraction bar 12, notice I said fraction bar, 12 sine 60, like I said it's easier to type that, than root 3 over 2, and then sine 72 degrees. Okay, we get 10.9 is length f, or equals 10.9. And guys, do write, only write a minimum amount, what you have to write in your exam paper, and write your answers nice and big. It just makes life easy for the examiner. 1 decimal place, who might not have eyesight like you have. 1 decimal place. Okay, we've done that. That's good. Moving on now to question 3. M, N and P, M, N and P, M, N is 26 centimeters, MP is 17, M and P is 17 centimeters, angle at M is 56 degrees. Calculate Pn. Well, I'm not going to call it Pn. I'm going to call it little m with a question mark, 1 decimal place. Let's make up a roster. And let's call it angle M. Calculate the other 2 angles in the triangle. So that will also be what? So calculate, that's side M, and side M, 1 decimal place, and the other 2 angles. What are the other 2 angles? Well, they're angle N and they are angle P. There's absolutely no reason in the world, because it doesn't cause ambiguity, there's no reason in the world to use the 3-letter form. Right. Now we have to put a different hat on now. We have to put our analysis hat on while we try and figure out what rule we're going to use. So as I said, this is a dead giveaway, the fact that you have that. It's a dead giveaway to say you're going to use the cosine rule. So the cosine rule, and I'll just get straight into applying it, because to be honest it's easier to apply it than to write it down in letters. So M is equal to the square. Now the square root and the square sort of cancel, so you can kind of see a kind of a, I hope you get a kind of a conceptual understanding what's going on. Well, why would I have a side equals a side squared? Well, it's being cancelled out by this. On the same token, that's double. It isn't a number. Well, it is a number, but it's doubling it. It doesn't have dimension of centimeters. And you have 26 by 17, which is a kind of like an area, but the square root of area is length. So this makes sense. And this is of course the correction for the fact that it's not a right angle and it's not Pythagoras. Minus 2 times 26 times 17 by the cos of the angle between them. So this correction factor has to double the 2 sides and the cos of the angle between them, which is the cos of 56 degrees. So let's just plug it into the calculator. Let's look for our condition here, 1 decimal place. You'll often forget where you were, so you'll often just go in and maybe type in on top what it was already. That doesn't matter. Square root of 26 squared plus 17 squared minus 2. Okay, I can handle the 2 17s. Well, let's just say I can't. Let's just go with a whole load of brackets this time. We'll try and assess Is it really worth all that effort putting them in? Probably not, but anyway, it's done now. Cos 56 degrees, close your argument sign, and we're good to go. So this is equal to length m, and it's 21.7 centimeters. You don't have to write the 1 decimal place, by the way. You've got it right, and you don't have to remind someone it's 1 decimal place. But what we do want to do, if we're going to use that on an ongoing basis, is to store it. So shift store if you're on the old calculator, which I am, because of the bigger writing right now. So shift store m, and if you're on this one, you know yourself, it's just store m. It's a bit quicker. Okay, so still work to do. So now rethink, reanalyze. Because that's that. You've used the cosine rule. Now what you want to do is get the angles. So either one will do. So how would I get this angle? To me it's looking like the sine rule, because you have so the question, could you use the cosine rule? Well, you'll only have a choice if you have 4, and if you I do have excuse me, I do have 4 pieces of data. So if I wanted this angle, yeah, I have all 3 sides and an angle. So say I wanted this angle. What would happen? I just want to see, can I use the cosine rule? N is equal to the inverse cos. And if I don't, well and good. I did some exploring, thinking outside the box a little bit. So the inverse cosine. And what am I odd one out? So I have... These two are the ones I like. These are the ones we kick off with. These are the ones that play the major role in the formula because they appear twice. Now, do I want to write 21.7? No, I've stored it to m. So if I want to be more precise, I write m squared, and I trust it. I've written here that I've put it into m, and it says it's still saying it on my calculator anyway. So I can hardly argue with that. So that what the reason for this is it's actually 21 point something else, 27.7 blah blah blah, or 21.6 and something bigger than 5. It's storing that precision in your calculator. So there's no reason to throw it out and to use incorrect or less precise data here, because maths is a precise endeavor. It's not like science where measurements have an error associated with them. There's been no error introduced since the original data has come, which we assume to be precise. That's the difference between maths and science. So you've 26 squared plus m squared minus double times 26m, where m is already a populated value in your calculator, all over. Now remember, you just look upstairs here and see what these are. So I know what 2 26's is 52, so let's get on with it and write that. Okay, the third angle is going to come out real quick from the 180 minus formula. Okay, so we'll get on with this and calculate that. So inverse cos, shift inverse cos, fraction bar, you do that all the time. 26 squared plus m squared, which required the use of the letter alpha, and there it is, m squared, minus, well, 2 26's times m, not minus 52m. That's not right, is it? That's not right. No, that should have been 17 squared, and we spotted it, so we're okay. Minus 17 squared, and that's if you know the shape of your formula well enough. These things happen. So I know you're probably going mad for the last 5 minutes saying that's wrong, and wanted to scream down at the screen at me. But look, I got there. Okay, so you've that squared plus that squared minus that squared up there. Okay, because that minus double the cross product doesn't happen in the cosine rule. Well, it does, but it happens down here. But it's not minus, it's plus. It's plus 52m like I have here. Okay, well, all's well and good. All's well that ends well. I didn't fall for it once I was copying my own work. So I'm downstairs now, and I'm literally going 52m, knowing that m can only be brought into it using that. Good. Okay. And out we go, and we close the argument for the inverse cos. It's a one-to-one function. It's a bijection, so we're absolutely certain there'll be an answer here, and we're absolutely certain it's unique. Okay, that's what a bijection is. 1-to-1. Well, it's it's surjective 1-to-1. And then it's also called, you can call it a surjective injective function, because that's what a bijective function is. 40.5 is the angle, to 1 decimal place at least. Look at that, correct to the nearest degree. So correct to the nearest degree. Well, I don't know. Do I know? No, I don't. Well, I know I'm going up actually, so I know it's 41 degrees. But just in case you weren't too sure, you could fix to 0, which is a way of saying only give me rounded to the nearest round, blah blah blah. Come on. What am I trying to say? Rounded to the nearest degree. Okay, now I'm going to go 180, but do I want to store that? I do. Have I got it in there? No. Shift store. That one there, whatever that is, F. Okay, so I'm going to do 180 minus 56 minus F. Is that right? Because N is, yeah, F. Be careful here. Clear 180 minus 56 minus F. And what they do, and we might change our policy because they just let propagations happen. So the answer there is 83 degrees. Okay, which is a bit silly because you've written both of them. Oh no. Yeah, so is it true that 41 and 83 and 56, let's just double check that there isn't anything totally stupid there. 83 plus 41 plus 56. You're doing as much sanity checks as you can. Okay, and that's good. That's question 3 done. We're flying through them. Not. I can speed up if you want me to. So in the triangle DEF, okay, let's speed things up. DEF. Is it? Yeah, because this is the unknown. So let's lie that unknown this way. Let the 8 go up at 62 degrees. And let the 11 try to come down. So I'll really get a handle on this by understanding what's 8 sine 62. So by going 8, because I want to know what this diagonal here is worth. It'll give me a conceptual understanding about what's about to happen. So 8 times the sine of 62 degrees is 7. And the length we want to bring down is 11, so there's only one solution. He's over here. Because he's not allowed to go back here, that would be silly. Would it? Yeah, because this angle then is external, not internal. That would be silly. Okay, so there's only one answer. Okay, now we don't need this anymore. But we know that if we try to get a second answer, it's going to blow up in our face because we're going to end up with more than 180 degrees inside. Funny enough, we don't have to go and add up all the angles. We already know it's too long. Okay? Because the only way for the ambiguous situation, we've got two values. We've got 8 here and then 7 for this. So the ambiguous case is when this length is between the 8 and the 7. I hope you can see that. Okay, that's an ambiguous case. 7 gives us a right angle triangle, and bigger than 8 gives us a single solution. Less than 7 gives us no solution. So if we call that length there x, x less than 7, no solution. Triangle doesn't exist. X equal to 7 is a right angle triangle. X between 8 and 7 is ambiguous with two answers for the angle, an acute and obtuse, and x is larger than 11 gives one unique answer. So what's funny is there's two ways to get a unique answer. You can get a unique answer when x is 7. You can get a unique answer when x is larger than 11. Isn't that funny? So if you draw that, you're going 7 gives a unique answer, and does it have to be larger than 11? It does. If it's equal to 11, what am I saying? Why 11? 8, I mean. So then you're going basically, but if it's equal to 8, what happens? It's only one answer can go that way, because if it comes this way, it goes back on itself. So, but larger than what am I trying to do here? I hope I've messed up the whole question, the original question, but I've certainly said you have a unique answer if x is larger than 8. So basically what we're doing is, if you want a unique answer, you're talking about being 7 or being larger than 8. Okay? Now there's another way we can go at this. Let's be more precise about our understanding of this sine rule. So you have an indefinite base. You have an angle A, and let's just call it side 1 and side 2. Or let's just say we know that, no, you can't have A there. Yeah, you can have A here opposite side A and B. Okay, so that's very clear to understand. So when we want to break up and analyze it very, very precisely, we say if A equals B sine A, you have a right angle triangle. If A, and let me put this as a sandwich, if A is less than B and greater than B sine A, so if A is in that sine, and think what sine A does, it modifies and shrinks B. So if A is in that sandwich, you have two solutions. And if A is bigger than B, you're back to one solution.